Good afternoon, ladies and gentlemen. Today we're going to quickly review solving systems of equations. Our goal is so that you come to class ready to go over more examples, more difficult ones, and then hop into some practice. So, solving systems of equations. What are systems of equations? Well, systems of equations are two or more, typo right there, Ms. Rance, two or more equations with the same number of variables. Now, the key thing to remember is that a solution to our system is going to be an ordered pair that makes all equations true. So we're going to be looking for an x value and a y value. And as you can remember from Math 1, we have three methods for solving systems of equations. The first method is by graphing, second is by substitution, and the third is by elimination. Graphing systems of equations. With graphing systems of equations, we graph the two equations and we look for the intersection. Our intersection is going to be our solution. So in this case, this intersection point is our solution. Is our solution. There is one solution in this case. Now, what happens if we have parallel lines? Parallel lines right here, you guys, right? They never intersect. So, our solution is actually going to be no solution. There is no solution because our lines never intersect, so they never share any x and y values at the same time. So we can never ever find any values that would be substituted into the equations of the lines such that it would make the equations true. Now our third case, when we're looking visually at what systems of equations look like and their solutions, is if when we graph the two lines, they are the same line. They are the same line. That means that we have an infinite number of solutions. Because whatever x or y value we put in, it will also allow us to have a true solution or true equation with our second equation because they are the same equation. Now, if you do not remember how to graph linear equations, no shame. All you need to do is let Miss France know, either Edmodo her, email her, or stop her in the hallway. Just let her know, and we will go over that. Okay, substitution is our second method, and it is replacing a variable with an equivalent expression. Our goal in using substitution is to create a one-variable equation. This is ideal when we already have one of the equations solved for. When that happens, it's a lot easier to use substitution. In this case, we have our system of equations. We have the first equation is x is equal to 10 minus 2y. Our second equation is 2x plus 3y is equal to 16. Now, notice here, we have one variable is already solved for. We know that x is equal to the expression 10 minus 2y. Well, since x is equal to that, we can simply take that expression and substitute it in for x. So everywhere I see x, I'm going to replace it with 10 minus 2y. And so I have 2 times 10 minus 2y plus 3y is equal to 16. Now I'm going to solve my equation for y. So I distribute, and I have 20 minus 4y plus 3y is equal to 16. Combine our like terms, and I have 20 minus y is equal to 16. I'm going to come up here. I have negative y is equal to negative 4. So y is equal to 4. That is only part of our solution. Now in order to get our second part, we need to find what x is. So we can actually take our value and substitute the y value that we solved for, y is equal to 4, into either of the equations, and we will be able to find our x value. The simpler of the two is to use the first equation. So I will have x is equal to 10 minus 2y. We know what y is, so let's substitute that 4 in. We have x is equal to 10 minus 8, which is 2. So x is equal to 2, y is equal to 4. So our solution is the ordered pair, because remember, graphically our solution is an ordered pair, is 2, 4. We will do more examples and practice with these when we come back to class. Now, our third method of solving systems of equations is elimination. When you hear the word elimination, I know I think of getting rid of something, or like single elimination in tournaments. Think get rid of. So our goal is to eliminate one of the variables, get rid of one of the variables, and we're going to do that by adding or subtracting the two equations. So if we look at our system of equations, we have the first equation is 3x plus 2y is equal to 7, and the second equation is 5x minus 2y is equal to 9. If we look, we need to ask ourselves, what is going to be easier to eliminate? Are we going to be able to add or subtract the equations and eliminate the x's, or add or subtract the equations and eliminate the y's? In this case, it's going to be easy to eliminate the y's, and we're going to do that through addition. So if I add my two equations, I'm going to add vertically down. So 3x plus 5x is 8x. 2y plus negative 2y is 0. Look at that. We have eliminated the y's. That was the whole goal. And 7 plus 9 is 16. So now I have 8x is equal to 16, and I can divide by 8. And I have x is equal to 2. Not done yet. You need to substitute that back in to find our y value. You can pick either of the equations. So I'm going to pick the first one. So I have 3 times 2, since x is equal to 2, plus 2y is equal to 7. So 6 plus 2y is equal to 7. 2y is equal to 1, and y is equal to 1/2. So our solution is the ordered pair 2, 1/2. When you guys get back to class, we will go into more examples of solving by elimination. You will practice some, and we will talk about what we do if neither of our variables are easy to eliminate right off the back. Just a little hint, a little teaser, which you may remember, we're going to have to multiply our equations by a number so that we can eliminate them. Now, in order to make sure I know that you studied this weekend, you're going to study your vocab, and I also need to know that you watched this video. So here's what I want you to do. Now, this doesn't work if you go and tell other people who did not watch the video. When you come into class on Tuesday, I would like you to write your name on the upper right-hand corner of your desk with a dry erase marker. That's all for now. I hope you enjoy your long weekend.